Alright, hello and welcome back everyone. This is problem 27 in my series of 35 videos, one for each question in an AP Physics C Mechanics multiple choice test. Let's jump right in. The graph over here shows a variable force F that acts on an object as it moves along a straight line as a function of time t. What is the change in momentum of the object from t equals 2 seconds to t equals 4 seconds? And the options it gives us for this are A, 1 kilogram meter per second, B, 2 kilogram meters per second, C, 4, D, 6, and E, 8. So let's look at this problem. What is it asking us for here? It wants the change in momentum. So that's represented as delta P. That's the variable we use for momentum. So what are we attempting to relate P to in this problem? We have force here, and the only other thing we have is time on this graph. So let's look for equations that we can use that relate or that deal with momentum and hopefully relate force and time, or if not, we can use another problem to get one of those variables. So some equations we have for momentum, we have P equals force times velocity. We've got one for force is equal to delta P over delta T. So yeah, that's a little bit hard to see. And that problem, the force is equal to delta P over delta T, is going to be more useful in this case because it relates all the three things we have, the two things we're given, force and time, as well as what we're trying to find, which is that delta P. So let's manipulate this problem, isolate the delta P because that is what we're trying to solve for. So I'm going to multiply by delta T on both sides, and that's going to be force times delta T is equal to delta P. So let's look at the time it's asking us for here. It's saying what is the change in momentum of the object from t equals 2 seconds to t equals 4. So that's going to be from this time to this time. So we're only concerned about this part of the graph going from here to here. Alright, let's see if we can plug in variables. So our delta t is going to be what? What is our end time is 4 seconds. Our start time is 2 seconds. So delta t is 4 minus 2 seconds, which is 2 seconds. Pretty straightforward. And now our force. So here our force is changing between 2 and 4 seconds, but it's changing linearly. So at 2 seconds our force is 2, at 4 seconds our force is 4. So what we're going to do here, because the force is changing linearly, it makes it easy for us. We can just take the average force and plug in the average force here. So again, if we're averaging 2 and 4, very easy, that's going to be 3. So let's start to plug our values in. We have an average force, there's not much space already down here, force average of 3. So plug in our force. 1 second. Yeah, our force is 3. Our delta T is 2, is equal to change in momentum. So change in momentum is 6, and that is solution D. So let's think about the units here for a second. So we're multiplying time, which is in seconds, times force, which is in newtons. So I guess that's going to mean that newton seconds, because if we're multiplying newtons here in newtons times seconds, a newton second is going to be equal to what it gives us as the momentum here, so kilogram meters per second. Alright, thank you for watching. Let me know if you have any questions about momentum, about force, about any of these things in this video or how I explained it. Like and comment. Thank you for watching, and check back in for video number 28.